All right, so we are ready for our last entry in our travel log. And so please pause me if you still need to get there and open that up. You'll find it on the page with the plate boundaries map. But the place that we visited is Mount Fuji in Japan. And so let's review quickly. California, slide by transform boundary, resulting in earthquakes. Iceland, divergent, which means the plates are pulling away. So magma can get out, cool into new crust, and push the old crust away. In Nepal, we had a convergent boundary, which means the plates were pushing, but it was a continental boundary, continental convergent plate boundary. So nothing sank since it was the same density of crust, and boom, we have Mount Everest, the highest mountain on the planet. Now, Hawaii, where we just came from, is a volcanic landscape, but here's the weirdest thing. It is not at a plate boundary. It's in the middle of the Pacific Ocean, where the Pacific plate, is moving over a hot spot where magma just rises up through the plate and melts that oceanic crust to make low viscosity lava flows. So now we get to Japan. And remember that Japan is in a plate tectonics nightmare of a situation, honestly. There are 4 tectonic plates that are interacting there, and it's a complex situation. But what's actually made Mount Fuji is a convergent boundary. But think about this. When I say convergent, your mind should be saying, oh, she means push. But this time, we do not have continental hitting continental. Finish my thought in your mind. This time we have continental hitting oceanic. And so this time I want you to type in the continental oceanic convergent boundary. And then I want you to watch something before we type the explanation. So when you see me bring this up, you're probably like, Mrs. Fickus, we've done that. That's Iceland. Look at the arrows going away. That's the divergent boundary. And I know, you're right. In Iceland, oops, I put that in upside down. In Iceland, the plates pull away. It allows magma to escape. It cools into new crust, but eventually the plates move apart more. And then the next batch of lava comes out. And then the plates move up more. And the next batch comes out and pushes the old crust away, and so on. So here's the thing. What's happening in the middle of the Atlantic Ocean is not the same as Japan. But now I want you to think back. What did we do with these ends? These ends that were by the continents. Remember, we took them and we took that oceanic crust and it sank underneath the continental. Now let's think this through. Why would oceanic sink under continental? Well, why does a rock sink in a pond? Because its mass is more tightly packed together. It's more dense. So as the continental and oceanic crust hit each other, the oceanic crust sinks and it starts to sing a song you might know. This oceanic crust goes, it's getting hot in here. I'm turning into magma. And as a result, you get magma close to the surface. But this magma is high in melted continental crust right here. And so that melted continental crust is high in tight fitting silica. So pressure builds till boom, you get a stratovolcano, an explosive eruption. Now, how do we say all of this business? So this is the longest explanation, and it's okay to pause me and go back, but here's what you need to type. 2 plates of different crust types pushed together. I underlined pushed together. I want you to also, that's our convergent word. Now, because the oceanic crust is more dense, it sinks and melts into magma. Now, here's a new term for today. It is called a subduction zone, this place right here where you have the melting oceanic crust as it sinks. Subduction is like saying another word for sinking, okay? Now, you're welcome to pause me if you need to finish that explanation, but I wanted to show it to you on this too. So this is what's happening in Japan, just like this model. Do you notice the oceanic crust sinking? As it starts to rise up in the continental crust, it's getting lots of bits of tight-fitting silica in it, and that behaves like a stopper here, and then boom, you get an explosive volcanic eruption. So this is a continental oceanic convergent plate boundary. The only thing I don't love about this diagram, they should have had arrows going in this way, pointing at the oceanic, but otherwise this is a perfect representation of the plate tectonic story in Japan.